Okay, so in this video what I'm going to do is have a look at manipulating equations or formula. So I'm going to do a lot of examples, and we'll just run through the procedures for each example. So let's start with a fairly straightforward one. Let's take d is equal to s times t. Now this is our speed, distance, time formula, so distance will be equal to speed times time. But let's say we want a formula for time. So all we got to do is get time on its own here. So we want t equals something with distance and speed on the left hand side. So you got to get rid of this part here. So what you got to ask yourself is, what is the s doing to the t? Well, the s is multiplied by the t. So what we will do then is do the opposite to multiplying. What we're going to do is divide. So we're going to divide both sides here by s. And what we end up with then is just simply, well, this s here will divide into this s and we'll get 1. So on this side here we'll get t. I'll leave it on the right hand side. And on the left hand side you can see we just end up with d divided by s. So now we have a formula for time here. So time equals distance divided by speed. So that's a fairly straightforward example. Let's have a look at another one. Now let's take x plus twice, let's say y equals 3 times z. Okay, so let's try and get let's say the y here. We'll try and get y on its own. So I'll just put it here. This is what we're aiming for. So what we want to do is try to isolate this y. So we need to get rid of this x and get rid of this 2. Now, if you remember previously, when you work through calculations, we used BIMDAS. So we look to see were there any brackets, then powers or indices, multiplying, dividing, adding, and subtracting. So really, when you're doing this kind of thing here, you're doing this in reverse, if you like. So we're starting with adding and subtracting first. We try to get rid of that, and then dividing and multiplying. We try to get rid of those. But we'll have a look at that anyway. Let's have a look. We have this x here added to this 2y. So we want to get rid of this x first of all. Then we're going to get rid of the 2, which is multiplied by the y. So let's see if we can do that. Now, first thing we're going to do is subtract this. You've got to ask yourself again, what's the x doing to the rest of the to this term here, if you like? Well, it's added. So we're going to subtract. There's a plus in front of this x here, so we're going to do the opposite to that. We're going to subtract x from both sides. So what we're going to do is write down x, we'll have the plus 2y on this side, we'll have the 3z on this side. So what we're going to do is we're going to subtract this x to get rid of it from this side, but remember it's an equation, so you've got to do exactly the same to the other side. So we're just going to subtract x from both sides. So what does that leave us with? Well, it's still the same equation. We've done the same thing to both sides, so we haven't changed the equation. So this will disappear. Here we'll just get 0. Here we're just left with plus 2y, or just 2y, and on the right hand side we get 3 times z minus x. Okay, so we're almost there. We just have this 2 stuck to this y here. So again, you've got to ask yourself, what's the 2 doing to the y? Well, it's multiplied. So what we're going to do is do the opposite to multiplying. We're going to do a division. So we'll write all this down. Now, what we're going to do here is divide by 2. We're going to divide this side by 2, and you must divide every other term by 2 as well. So we can divide the whole side by 2, so we can just put a line underneath here and put a 2 underneath, or we can divide each individual term by 2, so we can do this kind of thing here. Okay, so that's it. The next line then will just give us, this 2 will divide into this 2, we'll get 1y, so that'll just give us y. And this side, well, just 3 over 2z minus x over 2. And that's it really. This is our equation here. Remember, we want to get y on its own here. Okay, so that's another example. So let's try another one then. Let's try this one. Or minus 4u is equal to pt. And let's say we want to get u on its own. So this is something similar to what we did up above. So okay, we want to try and get u on its own. So down here we want to end up with u is equal to everything else. So let's start. Well, we've got this or here. We want to get rid of that first. Okay, so we've got to ask ourselves, what's the or doing on this side? Is it adding, subtracting, multiplying, or dividing? Well, it's plus or minus 4u. So how do you get rid of a plus or? You're just going to do the opposite to plus. You're going to do minus. So you're going to write down, this is a plus or here. I'll leave the 4u there. We have a pt here. Now it's a plus r, so I'm going to put in a minus r on this side, minus r on this side. So what will happen here then is we'll get r minus r is 0, so we'll end up with minus 4u here, and we'll end up with pt minus r on this side. Okay, so now we've got to look at this minus 4u here, and again, what's the minus 4 doing to the u? Well, it's actually multiplied. It's minus 4 multiplied by u. Don't make the mistake of thinking that you got to put in a plus 4 here. You got to ask yourself what's actually happening in this part here. Right in here, we've got a multiplication sign, this sign here. So what we've got to do is do the opposite then. So we've got to divide by minus 4. So we've got a minus 4u here. We've got pt minus r on this side. And what we're going to do is divide by minus 4. And again, I'll divide the whole side here by minus 4. Okay, so let's do the last line then. Well, this is minus 4 divided by minus 4. It'll give me 1u here. And on this side, I'll end up with pt minus r divided by minus 4. Now, it's usually a good idea here when you've got a minus here, maybe just to change that around. So I'm going to get u here. I'm going to multiply the top and the bottom by minus 1. So if I multiply this and this by minus 1, I'll get minus pt plus r, and on the bottom I'll get 4. So all I did was multiply the top and the bottom by minus 1. So in other words, I multiplied by minus 1 over minus 1, which is just 1. So I haven't actually changed this. I've just multiplied this fraction by 1. And the reason I did that was just to kind of tidy it up a little bit. Here we got r minus pt over 4. So I've got no negative signs at the beginning of each expression here, the numerator or the denominator. It's the same thing anyway. Okay, so that's another one. Let's see. Let's do another one. Okay, let's take. Let me just change this. Okay, so we're going to do r minus 2rs, and that's equal to q. And again, we're going to take r out here. We're going to try and isolate r here. Now, when you look at this here, you can see that there's an r here and an r here. You can't add these two or subtract these two terms. So how do we go from two r's to one r? Well, what you got here is two terms. You got this term here and this term here, both with a common factor. So what you do really is factorize this side of the equation. So what I'm going to do is take r outside the bracket here. R times 1 here will give me r. Then minus 2s here. R times minus 2s will give me minus 2rs. So all I've done is really factorize the left-hand side by finding a common factor of r. Now you can see initially we had two r's here. Now we've only got one r. So that's exactly what we want. Now we've got to get rid of this big chunk here. This is an r multiplied by this thing here, multiplied by this bracket. So what's the opposite to multiplying? Well, it's just simply dividing. So what we're going to do is just simply divide by this thing here. Divide by the bracket here, if you like. So let's do that. So I'm just going to put a line underneath here, a line underneath here, and I'm going to divide by 1 minus 2s. 1 minus 2s on both sides. All of this here will divide into all of this here to give me 1. And I'll just end up with r on the left hand side and q over 1 minus 2s on the right hand side. And that's it. Okay, let's just do another one then. Okay, so let's take a is equal to p over p plus b. And we are going to isolate p this time. And again, look, we've got two p's here. We got one here and one down here. So at some stage we're going to have to do some kind of factorizing to change them from 2p's to 1p. So let's first of all, let's try and get rid of this fraction here. Whenever there are fractions, usually a good idea to try and get rid of them first. Fractions and brackets and powers and square roots, try to get rid of them if you can. So what are we going to do? Well, let's get rid of this fraction. The way you get rid of fractions is you look at what's on the bottom here. There's a p plus b on the bottom. This p plus b is divided into this p. So what's the opposite to dividing? Well, it's multiplying. So what I'm going to do here is take the p plus b, and what I'm going to do is multiply both sides by p plus b over 1 if you like. So I'm going to multiply by p plus b over 1. So how will that help? Let's see. Well, on the left hand side I'll end up with a times p plus b, because remember this is just a over 1, so top by top, bottom by bottom. And on the right hand side I'll end up with, well, this here is multiplied, so what I can do here is divide this p plus b into this p plus b here to give me 1. So on the right hand side I just end up with p. Now the reason I did that was just to get rid of the fraction here. I still have to try and isolate these two p's, so let me get rid of these brackets now. So what will happen here is that I'll end up with a times p and plus a times b is equal to p. Okay, so we got rid of the fractions, we got rid of the brackets. So now let's just put this p and this p together. So how do I do that? Well, let's take this and just bring it over here. How am I going to do that? Well, let me just write it down first. Okay, so let's just get rid of that. Now, what am I doing here? Well, what you have to ask yourself, well, what's this AP doing here on this left hand side? Well, it's adding. There's a plus AP here, so what I'm going to do is put in a minus AP on this side, a minus AP on this side, and that should get rid of it for me. So plus AP minus AP will give me 0, and on the left hand side I'll end up with AB is equal to P minus AP. Okay, almost there now. So let's see, I've got the two p's together anyway, so put the AB here. Now what we did in the previous example was whenever there are two p's together we can factorize. So take the p outside the bracket here, p times 1 will give me p times minus a will give me minus ap, and then the last step then, what I've got to do here is just look at what's this p doing to the 1 minus a? Well, it's multiplying, so what I'm going to do is divide by 1 minus a, divide by 1 minus a. So that will finally give me AB divided by 1 minus a is equal to, well, that will divide into that, or divide by that, and I'll end up with p. So that's it for that example. A little bit more complicated, but same idea again. So let's see. Let's have a look at another one. Okay, so let's look at one with maybe a square root in it. Okay, so let's have a look at t is equal to 2 pi times the square root of L over G. Okay, so in this particular case, let's try and get, well, we'll try and isolate the G here, let's say. Okay, so now let's see. This 2 pi is multiplied by this square root here. So there are a number of ways of approaching this, but usually what I like to try and do is maybe isolate the square root, get the square root on its own first of all. So this 2 pi here is multiplied by this here, so what we're going to do is divide both sides by 2 pi. So on the left hand side I'll end up with t divided by 2 pi. On the right hand side all of this will be divided by 2 pi, so we'll just get 1. So that will just give me the square root of L over G. So on the right hand side all I really did here was 2 pi times the square root of L over G divided by 2 pi. So that will divide by that, and I just end up with this part here. Okay, so now whenever there are square roots, it's a good idea to square both sides to get rid of the square root, because the opposite to a square root is a square. For example, 3 squared, if I square root that, the square and the square root will cancel each other out, if you like, and I'll just end up with 3. So, or if you think about it, 3 squared is 9, the square root of 9 is equal to 3, so it's the same kind of thing. Okay, so we're going to square both sides. So the way you square a fraction is you square the top and you square the bottom. So on the left hand side we end up with t squared over, if you square 2 pi you get 4 pi squared. So on the right hand side, the square, if I square the right hand side, the square root will disappear. So I'll just end up with L over G. Now remember, we want to isolate the G here, so just running out of room here, so this is going to be the last example, but let's see. What we're going to do here is, now we've got 2 fractions, okay. On the bottom of this fraction here we've got a 4 pi squared. On the bottom of this fraction here we've got a G. So what I'm going to do is multiply across by all of these things on the bottom here, the lowest common multiple, if you like. Now another way of looking at this, whenever you've got a fraction equal to a fraction, what you can do, what's called cross multiplying. You can take the top here, multiply by the bottom, and that will be equal to the bottom here multiplied by the top. But I'll show you how that works. Really what you've got here is, on the left hand side we have a t squared over 4 pi squared. On the right hand side then we have L over G. Now I'm going to multiply both sides by 4 pi squared G all over 1. 4 pi squared G over 1. How does that help? Well, this 4 will divide into this 4 and I'll get 1. This pi squared here will divide into this pi squared. So I'll just come up here, so I get, on the left hand side I'll get t squared times G. The fraction is gone here, there's no denominator anymore. On the right hand side what happens is I end up with this G here dividing into this G here, and I'll just end up with L times 4 pi squared. So now I've gotten rid of the fraction, so I got rid of the square root by isolating it and squaring both sides, and then the fractions by multiplying across by the lowest common multiple of the denominators. Now if you look at this here, this is really, remember I said you could cross multiply. If you take this G and multiply it by the top here, you get G times the top, this part here. This is what I've ended up with. On the right hand side, take the bottom multiplied by this part here, you end up with 4 pi squared L. That's what I've ended up with here. So by multiplying across by the denominators multiplied, you effectively just end up cross multiplying. Okay, so what did we want to do with this anyway? I've kind of forgotten at this stage, so let's see. We wanted to isolate the G, I think it was, wasn't it? Yep, we want to isolate the G. So let's see, there's the G there. So what are we going to do here? Well, that G is multiplied by this t squared, so let's do the opposite. Let's divide by t squared. Divide by t squared. So we end up with this t squared will divide by this t squared, and we'll end up with G. On the right hand side we end up with L. We'll put the 4 first. 4L pi squared over t squared. And that's it. I've done quite a few examples there of how you manipulate equations or formula. So you just need to practice these and you'll get fairly quick at it after a while.